Hi, welcome to this video. In today's video, I'm going to look at a very interesting sum. We have sum of 1 over n squared. So in order to calculate this sum, I'm going to use the Fourier series of nx plus bn multiplied by sine of nx as n goes from 1 to infinity. Okay, this one is called Fourier series. We have a naught equal 1 over pi, the integral multiplied by integral from minus pi to pi, okay, f of x dx. Okay, we have also a sub n equal 1 over pi multiplied by integral from minus pi to pi and x dx. Okay, so we have b sub n equal to 1 over pi from minus pi to. It's very important and useful formulas, especially in the physics. I'm going to choose the function where I can find more simplifications in this formula. Okay, let's choose the even function. Let's set f of x equal to x squared. This is even function. Okay, a naught equal to 1 over pi minus pi from minus pi to pi x squared multiplied by dx. As you know, this is even function. Is symmetry for the vertical axis, so I will have 2 times pi from 0 to pi, so I will have x squared dx. This one equal to over pi. I'm going to look for the primitive of this one, which is 1 over 3 x 1 over 3 multiplied by x cubed, the bound from 0 to pi, which is 2 pi. This one is giving us 2 over 3 1 over pi. This one is giving me pi cubed minus 0, which is 2 over 3 pi square. Okay, a naught equal 2 over 3 pi square. Okay, this is the value of the first one, a naught. I'm going to evaluate a sub n. Okay, we have a sub n equal to 1 over pi multiplied by integral from minus pi to pi f of x squared multiplied by cosine nx dx. Okay, we were at this expression I sub n equal to 1 over pi multiplied by integral, as x goes from minus pi to the pi, x squared multiplied by cosine nx dx equal to times of this integral, because this function is even function, because cosine x is an even function. Okay, so in order to evaluate this integral, I'm going to use by part. Okay, this is by part expression. Okay, so now I'm going to evaluate this now. So I will have a sub n equal 2 over pi. So I'm going to set du equal to cosine nx. Okay, and v equal to x squared. So my integral become 1 over n sine of nx, because the primitive of cosine nx, which is 1 over n sine of nx, multiplied by x squared, the bound from 0 to pi, okay, minus integral 1 over n, because the primitive of cosine of nx, which is 1 over n sine of nx, multiplied by derivative function of x squared, which is 2x. I'm going to bring number 2 outside. I will have x dx. Okay, from 0 to pi. As you know here, this integral become equal to 0, because sine of x equal to 0, the whole thing will be 0, and then minus, if you plug the 0 into x is giving you, if you plug 0 into x squared is giving you 0, so that means the whole thing is equal to 0. So I will have a sub n equal this one multiplied by this one minus 2 over n, this integral from 0 to pi, we have this one minus 4 over n pi multiplied by this integral, which is x multiplied by sine of nx dx. Okay, now I'm going to evaluate this integral as well. I will do the same thing. I'm going to use by parts in order to evaluate it. So now I have this one. Let's call it I integral. Let's call it I integral equal to from 0 to pi x sine of nx dx. I'm going to do the same thing. Du, in this case, du equal to sine of nx. So in this time I'm going to set du equal to sine nx and v equal to x. Okay, the perimeter function of sine nx, which is minus 1 over n cosine nx multiplied by x, the bound from 0 to pi, okay, minus integral of the primitive function of sine of nx, which is minus 1 over n cosine nx. With this sign it will become plus. Okay, so I will have cosine nx multiplied by derivative function of x, which is 1, we'll have dx. Okay, from 0 to pi always. I'm going to evaluate this part. So I integral become minus 1 over n multiplied by this x, which is pi, cosine of n and pi, okay, minus if you plug minus 0, if you plug the 0 into x is giving you 0, this one equal to this one, so plus this integral. If I'm going to look for the primitive cosine of nx, which is 1 over n sine of x, okay? So this integral become 1 over n sine of nx, this one, the bound from 0 to pi, okay? So this one equal, which is minus, this integral become minus pi over n multiplied by minus 1 to the n. This integral equal to 0 because sine of pi equal to 0, okay? So this one, now this one, so the I sub n equal to this one multiplied by I integral, which is I sub n equal to minus 4 over n pi, and pi multiplied by minus pi over n multiplied by minus 1 to the n. Minus with this minus become plus. This pi will be cancelled out. I will have 4 over n squared multiplied by minus 1 to the n. Okay, so this is the value of a sub n. I'm going to bring this one at the top and continue with our problem. Okay, so now we already find out these values. E naught equal to 2 over 3 multiplied by pi square, and a sub n equal to 4 over n square multiplied by minus 1 to the n. Okay, now I'm going to plug this one into this function. B sub n sine of nx, as n goes from 1 to infinity, equal to 0, v sub n equal to 2 over pi from 0 to pi, integral from 0 to pi, f of x squared sine nx dx equal to 0. Okay, we have the sum of b sub n multiplied by sine nx equal to 0 because this function x squared multiplied by sine nx is an odd function. That's why this integral equal to 0 as a periodic function. Okay, so now what's left? We'll have f of x equal to a naught over 2 plus the sum of the a sub n multiplied by cosine nx as n goes from 1 to infinity. So this one a sub naught over 2, which is 2 pi square over 3 multiplied by 1 over 2, okay, plus this one a sub n we already evaluated, which is 4 over n square multiplied by minus 1 to the n as n goes from 1 to the infinity multiplied by cosine nx. Okay, this is x squared. What I'm going to do now, I'm going to calculate f of pi, okay, which is pi squared. In the same time, this function equal to this function. This even function, this function equal to the Fourier series function as well. So, which is 2. I'm going to cancel number 2 from numerator and denominator. I will have pi square over 3 plus, I'm going to take number 4 outside as a constant. So we'll have 4 minus 1 to the n over n squared as n goes from 1 to the infinity cosine and pi multiply plus 4 multiplied by the sum as n goes from 1 to plus infinity. We have minus 1 to the n over n squared multiply cosine and pi, which is minus 1 to the n. Okay, so we'll have pi square over 3 plus 4 minus 1 to the n minus 1, which is plus 4 minus 1 to the 2n over n squared as n goes from 1 to plus infinity. So minus 1 to the n, which is 1. Okay, we will have pi squared over 6. Okay, now the sum of 1 over n squared as n goes from 1 to infinity equal to pi squared over 6. Okay, I have done with this problem. Thank you for watching. I will see you in next video. Bye.